Oh, hello, welcome back. Let's continue from where we stopped. Another type of isomerism we want to discuss is called geometric isomerism. Geometric isomerism. This is the existence of compounds with the same molecular formula but are not identical because of different special arrangements of the component atoms. The same molecular formula but they are not, based of the arrangement, they are not the same. In the case of both 2-in, we have both 2-in, but we have cis and trans. Now, in the case of the first one called the cis, now look at the normal compound organic nature of both 2-in is given like this. This is the in functional group. But because of the kind of isomer it possesses, all right, so cis but 2-in means the other alkyl group will be at the same side. CH3, then we have H. CH3, we have what? The H. So when we have the alkyl group at the same side, we call what? Cis. But the name remains. This is 1, 2, 3, 4, called butene. With two functional groups, with the functional group attached to carbon 2, we have 1, 2, but 2-in. But because of the alkyl group are attached to the same side, that's what we call cis. So this is your cis, but 2-in. Whereas the trans is the opposite. The trans is when you have the alkyl group in the opposite direction. That's just the difference. But they have the same what? The same molecular formula, but different structure with different chemical compound or properties. That's an example of what? Of a geometric isomerism. Another example is cis 1,2-dichloroethene. You can try the structure by yourself, it's not difficult. Pick the main structure, which is 18. Then attach one up, one down, one up for the cis. Then the opposite. Or let me do it for you. Let's try it together. This is your parents' tin, 1,2-dichloro. So this is carbon 1, this is carbon 2, this is chloro, this is chloro. Then the other is what? Is your, that is all. This is your cis 1,2-dichloroethene. Whereas the trans is just the opposite. One chloro here, one chloro here. So this is your H, this is your H. So this is a transform. This is a transform, while this is the cis. The cis form of 1,2-dichloroethene. Okay, let's continue. Geometric isomers have similar chemical properties, yes, but their physical properties are different. All right, the last one is called the optical isomerism. Just like you are standing in front of a mirror, when your left becomes your right, and your right becomes your left. Bring that idea to chemistry. This is the existence of two or more compounds with the same molecular formula, but with different configurations. And because of molecular symmetry, they rotate plane polarized light. Example, the lactic acid. Look at this. You can see this is the lactic acid. It reflects, is the opposite. This becomes this. So the same structure, but what? Sorry, same molecular formula, but different what? Structure. Okay, that will take us to alkanols. Alkanols, on this, we're going to look at brief description of alkanol, how to classify alkanol based on their alkyl group, then lab preparation of the ethanol, precisely industrial preparation of ethanol, physical properties, chemical properties, and their uses. All right, what are alkanols? Alkanols are compounds containing hydroxyl, OH. And once you have OH in a compound, that compound is what? Is an alkanol. Some people call it alcohol. The same thing, either alkanol or alcohol, they are the same. They form a homologous series with general formula of CnH2n plus 1 OH. There must be OH to show that this is what? Is an alkanol. Or CnH2n plus 2O. They are named by dropping the end minus E from the alkane. For example, alkane, if we release this E and add what? OL, you give us what? No. So alkane, this one is gone, alkanol. So this is the parents of the alkanol members of the molecular series. Then we can classify them based on alkyl group. The first one is called the primary alkanol. This one is when you have alkyl group, only one alkyl group attached to what? Carbon carrying the OH. This has only one alkyl group attached to the carbon that carries the auxiliary group. General formula is CrC2OH. Okay, for example, this is general structure. This is an example of a primary alkanol. You can see now CH3, this is the only alkyl group. The rest are OH with the OH functional group, ethanol. Okay, secondary is simple. Secondary alkanol have two alkyl group attached to the carbon that carries the OH group. R and what, and the H. This is a general structure. R2CHOH. This is the format for what? Secondary alkanol. Then for example, propan-2-ol. Propan-2-ol. Then the last one is tertiary alkanol. We have three alkyl group attached to carbon that carries the OH. Example, 2-methyl-propan-2-ol. This is 1, 2, 3. This is the propan-2 because OH is added to carbon 2. This is carbon 1, carbon 2, carbon 3. Carbon 1, carbon 2, carbon 3. So carbon 2 carries the nol. Carbon 2 also carries all the alkyl. So we have 2-methyl-propan-2-ol. 2-methyl-propan-2-ol. An example of what? Tertiary alcohol. Okay. Then let's take the first one, the first member of the alkanol, which is ethanol, because they have the same chemical properties, the same mode of preparation, because they belong to the what? The same homologous series. All right, ethanol can be prepared in the laboratory by hydration of 18. That means adding water to 18. As you can see, this is 18 C2H2 with double bond. When water is added to it, you have what? Ethanol. The second method is by reducing ethanol with nascent hydrogen in the presence of platinum catalyst. This is your ethanol, CH3CHO, ethanol plus nascent hydrogen to give us what? Ethanol. Then 3, hydrolyzing iodoethane with an alkaline. This is iodoethane. This is iodoethane. This is sodium hydroxide. When you hydrolyze these two, you give us what? Alkanol, with the release of sodium iodide. Number 4 is hydrolyzing ethyl esters with a hot alkaline. So this is an ester, precisely ethyl, C2H5. Ethyl ethanoate. Ethyl ethanoate with what? Potassium hydroxide. You give us what? Ethanol and potassium ethanoate. Okay. Industrial preparation. 1. Preparation from 18. So what happened here? 18 is first absorbed in an acid. 18 plus acid will give us what? Ethyl hydrogen tetraoctosulfate 6. Ethyl hydrogen tetraoctosulfate 6. Then you now hydrolyze this compound with water to have what? Ethanol. So that is, it takes a two-phase production. Acid plus ethyl give us what? Ethyl acid plus water will give us ethanol and H2SO4 as the other product. The next one is by fermentation. Very simple, by fermentation. So what is fermentation? It is a process, it is slow decomposition of a large organic molecules. We call them starch. Okay, by microorganisms, example, yeast and other bacteria, into smaller molecules. Ethanol. Enzymes which are secreted by these organisms act as catalysts for the breakdown of the sugar molecules. So this is illustrated in a compound chemical equation. This is your what? This is your glucose. Your big, large what? Large molecule. Enzyme act on it, and you release what? Carbon dioxide and ethanol at the end after some days. Okay, physical properties of ethanol. It is a colorless volatile liquid with a characteristic taste and smell. All of us, we are conversant with ethanol, alcoholic drink. They have a specific taste that you can notice anywhere. And they are volatile, means that they can evaporate easily. at high temperature. It is readily soluble in water in all proportions. Why? Because of the presence of the hydroxyl OH group. It has a boiling point of 78 degrees Celsius and no actions on litmus paper. All right, chemical properties. 1, combustion. So they react. They are combustible with a palpable flame, yielding water and carbon dioxide. As you can see, ethanol plus O2 give us what? Water and carbon dioxide. And this is a common reaction to all organic compounds. Whether methane, propane, butane, they all undergo combustion and they release the same products, water and carbon dioxide. Reaction with sodium and potassium. Ethanol reacts with sodium and at room temperature to produce hydrogen and sodium ethoxide. As you can see, this is ethanol with sodium, this is sodium ethoxide, which further what? Hydrolyze to give us what? Ethanol. Ethanol with sodium give us what? This is called sodium ethoxide. Now to leave this and hydrolyze in water, dissolve it in water, you give us what? Ethanol and sodium hydroxide as a byproduct. Oxidation reaction. Okay, ethanol changes to ethanol at first. Okay, ethanol is readily oxidized to ethanol, yes, by warming with acidified K2Cl2O7 solution. This acts as what? As an oxidizing agent that oxidizes what? Ethanol to ethanol. Okay, when you further oxidize it again, you give us what? A carboxylic acid in form of what? Of ethanoic acid. As excess oxidation, more oxidation, give us what? Carboxylic acid. At first, it is what? Alkanal group. Ethanol. When you further oxidize it again, we give us what? Carboxylic what? Acid. According to the equation. All right. So note, wine sometimes becomes sour on prolonged exposure to air because of the bacterial oxidation of ethanol to what? Ethanoic acid. Most people would like drinking palm wine. If you keep it for a longer time, you know, the taste will change because of what? There is an oxidation process that have taken place. From normal sweet taste of ethanol to alkanal, you keep it for a longer time, you change to what? An acid. So it's not very, very, very good to drink a fermented palm wine because it has changed to what? To acid. It may react to our system. Okay, note the following two. Primary alkanols are oxidized to alkanals and carboxylic acid, whereas secondary alkanols to alkanones, while there is no oxidation to what? Tertiary alkanol. Note, this is where question always come from. All right, esterification reaction, yes. This is a reaction between an between an alkanoic acid and an alkanol to give us an ester called alkanoates with the release of water as a byproduct. If you look at the formula, this is an alkanol, for example, precisely ethanol, reacting with what? Ethanoic acid. This is alkanol, this is what? Alkanoic acid. Now, the product is called an ester or what? Alkanoate with what? Water as a byproduct. So this process is called esterification reaction. Please note the equation very well because it always occurs in exams. All right, dehydration means what? Removal of water from ethanol. With excess concentrated acid at high temperature, ethanol reacts to form ethyl hydrogen tetraoctosulfate 6, which then decomposes to yield what? Ethene. So when ethanol is dehydrated with excess acid, the product is always ethene. Look at the equation very well. Ethanol plus acid give us what? Ethyl sulfate 6 with water as byproduct. Then when this compound decomposes, you give us what? Ethene. So high acid, more of the acid give us what? Ethene. But more of the alcohol give us what? Give us an ether group. Ethyl ethanoate. Or ethyl what? Ethane, ethoxy ethane, and ether. When you have excess of alcohol in dehydration, the product differs. Or when you have excess of what? Excess of concentrated what? Acid. So the equation is clear. Ethanol plus H2SO4 give us this that will lead to ethyl ethoxide with excess what? Alkanol at lower temperature. Okay, let's go for a brief break. When we come back, we continue. Thank you.